For section 10.5, we're going to take notes right now. There are a few vocab terms, quite a bit in this section. So we're going to fill these notes out and do a few problems together. Please note that when you are doing notes, I expect you to write everything that I write on the video onto your piece of paper. So I want you to draw the figures as well as fill in the blanks. All right, for an inscribed angle, an inscribed angle is an angle whose vertex is on. So let's write vertex is on a circle and whose sides are determined by two chords. So inscribed, think it's inside the circle. So we could put a point there. That'll be the vertex. And a chord goes from one point on the circle to another. And we have two of those. So that would be an inscribed angle. All right. A tangent chord angle is an angle whose vertex, again, is on the circle and whose sides are determined by, it says it in the name, a chord and a tangent, because it's the tangent chord angle. All right, so a chord and a tangent that intersect at the tangent's point of contact. And what that means is it intersects where the tangent touches the circle. So if this is a tangent line, great. A tangent chord angle, we are now going to add a chord. So the angle is this whole angle from here to here. That would be a tangent chord angle. All right, next we have a chord-chord angle. All right. A chord-chord angle is an angle formed by two chords that intersect inside a circle, but not at the center. So I realize that an inscribed angle, you're like, well, that's made of two chords, but this time they're going to cross each other, the chords. So if this is the center of the circle, let's have this chord go from here to here, and another chord go from here to there, okay? And so the chord-chord angle would be right here. I mean, there's four of them technically. And yes, you have vertical angles, which you are going to use that property when we solve for the measurements of these angles. Okay, we have a secant-secant angle. A secant-secant angle is an angle whose vertex is outside. So this is the first time it's outside a circle, and whose sides are determined by two secants. So if you remember, a secant is a chord that continues outside the circle. So if we let's put point P, this would be a secant-secant angle. It's made up of two secants, and the vertex is outside the circle. A secant-tangent angle, again, its name tells you what it's going to be made up of. It's an angle whose vertex, again, is outside the circle and whose sides are determined by a secant and a tangent. So here would be a secant. Remember, it's a chord. It goes through the circle. And now a tangent, the tangent only touches the circle at one point. So if I go like that, then that would be a tangent. And you could extend it if you want. It doesn't matter. But this angle right here would be your secant-tangent angle. And finally, for the different angles, we have the last one, which is a tangent-tangent angle. And that is an angle whose vertex is outside the circle and whose sides are determined by two tangents. So if I put a point here, let's put a point of contact here and here. That and right there, and the angle would be right there. That would be a tangent-tangent angle. Okay. Now, let's talk about the theorems. and how we determine the measurements of these types of angles, because there are specific rules. So the measure of an inscribed angle or a tangent chord angle is, and realize that these have a vertex on the circle. You have your inscribed angle that looks like this, or your chord-tangent, which if you had a chord there, the tangent would go there, so we're looking at that angle, is 1/2 the measure of its inscribed arc. Okay. The measure of a chord-chord angle, so chord-chord, and this is, remember when we have the X in the middle, or it doesn't go through the center, but it's the X goes, the middle of the X is somewhere inside the circle. Okay. The measure of a chord-chord angle is 1/2 the sum of the measures of the arcs intercepted by the chord-chord angle and its vertical angle. And you're like, what are you talking about? We will go over these. And last theorem states that the measure of a secant-secant angle, a secant-tangent angle, or a tangent-tangent angle. Remember, all of these have the fact that their vertex is outside of the circle in common. So the measure of those is 1/2 the difference, so we're subtracting here, of the measure of the intercepted arcs. All right, so we need this one, just so you know, let's go back to theorem 87. This one was 1/2 the sum of the measures of the arcs. This is my inscribed angle, and this one is my tangent chord angle. These two, what they have in common is that their vertex is on the circle. Okay. And we said the measure is just going to be 1/2 the inscribed arcs. So what they mean by inscribed, if we're looking at number 1, example 1, if this is a BC angle, the inscribed arc would be arc AC. Okay, because if this was my angle, that arc would be inside that angle. Okay, if we extend the rays. Now, the directions are telling us that the measurement of arc AC is 112. That means that the measurement of angle B is 1/2 that arc. So if we take half of that arc, the measurement of angle B ends up being 58 degrees. It's as simple as that. Again, same rule, because the tangent or the vertex is on the circle for the tangent chord angle. So the measurement of this angle right here, okay, would be half of the inscribed arc. And the inscribed arc for this goes from to D, arc ED. So it tells you, given that FE is tangent to E, the measurement of DE, arc DE, is 80. So that means angle DEF, the measurement of angle DEF is 1/2 of 80, which means the measurement of angle DEF is equal to 40 degrees. All right, so that's that one rule. Let's go down to the bottom one. The second theorem that we were told was for the chord-chord. So I'm going to write chord-chord over here. And the rule states that the angle is 1/2 the sum of the measures of the arcs intercepted by the chord-chord angle and its vertical angle. Okay, we need to find the measurement of angle Y. That's great. The problem with finding Y is that I don't have any information about its inscribed arc or its vertical angle, which is right here, that inscribed arc. I don't know that information, and that's fine. So it just adds a little bit of layer here. What I do know is that the arcs for AD and the arc for BC are 29 and 47. So what we're going to do is I'm going to find the measurement of, let's label this X. All right, and obviously it's X over here because they're vertical angles. So the measurement of angle X is going to equal the sum of those two inscribed arcs. So the sum of 29 and 47, and I should say half the sum. And then we're going to take half of that. So half of, what do we have? 76. And then when you take half of 76, you end up with 38 degrees. So that's X. Let's erase one of these and we'll write 38 in there. Now to figure out Y, well, they're supplementary. So Y would equal 180 minus that 38. So you end up getting 142 degrees for the measurement of angle Y. All right. Now, the last rule goes for these happen to both be secant-secant. So both of these are secant-secant. And if you notice, let's use a highlighter. For the secant-secant angles, they contain two inscribed arcs. You have one arc here and you have one arc here that are inside that secant-secant angle. And the theorem states that the measurement of the secant-secant angle is half the difference of those two arcs. So the measurement of angle A would equal 1/2, and then the difference means subtraction. So 100 minus 20. 1/2 of 80 gives you a measurement of 40 degrees for the measurement of angle A. So for the chord-chord, we add and then take half. And for secant-secant, we subtract and take half. So for angle C, it says, given segment AB is the diameter of the circle, P, BD is arc BD is 20 degrees. So this is 20 degrees right here. And arc DE is 104 degrees. Find the measurement of angle C. So in order for me to find the measurement of angle C, I need the inscribed arc. So I need this 20 degrees, but I also need arc EA. And the reason why they told us that BA was the diameter means that we're cutting the circle in half here. So that means all of this right here would be 180. And I need this measurement. I can figure it out because I have 20 plus 104 plus arc EA is going to equal 180 degrees because that's half of a circle. So 124 plus arc EA is equal to 180. When I subtract 124, arc EA is going to be 56 degrees. So now I could put 56 degrees there. And then to figure out the secant-secant angle measurement, we have the measurement of angle C is going to be half the difference of the two inscribed arcs, which are 56 minus 20. So 56 and 20. Half of, what do we have? 36 is going to give you a measurement of 18 degrees for angle C. Okay, here are quick 4 questions that are going to be similar to the IXL you're going to do today. So it asks you to find the measurement of angle HIJ. So HIJ is right here. We know that it is half of this arc. Well, we know the measurement of the arc because this angle is a center angle. And remember that arc is equal to the center angle. So then the inscribed angle right here would be half of 101 degrees, which would be 50.5 degrees. Find the measurement of G. Okay, well, G is a central angle. It has the center of the circle as its vertex. We know that this inscribed angle is going to be half of the arc. So 72, if we double that, we get 144 for that arc, which means angle G is 144 degrees. So we're combining two sections right now. All right, for angle TUV, so we're trying to figure out this angle right there. It's going to be half of this arc. Well, I don't know that arc, but I know that if this is the center of the circle, 109, that angle is congruent to this arc. So that arc is 109. This angle UWV right here is going to be, and I should do that so they're not congruent. Okay, is going to be the same as this arc, which is 131. So now an entire circle is 360 degrees. So if we have 131 plus 109 plus arc TV is equal to 360, we end up with 140 plus arc TV is 360. When we subtract the 140, we get that that arc is equal to 220. So if this is 220, the measurement of the inscribed angle TUV is going to equal half of that, so 110 degrees. Okay. Next, for this one, we want to figure out the measurement of VUW, this angle. It will be half of this arc. We don't know what that arc is, but we know that since this angle is 109, this arc is 109. We also know that UV is the diameter because it goes through the center of the circle. So 109 plus arc WV is going to be 180, since that's half of your circle. So arc WV will equal 71 degrees. If this is 71 degrees, then the inscribed angle right here would be half of that, which would give you 35.5 degrees. So biaxial you're going to do just deals with inscribed angles. You deal with inscribed angles as well as central angles. And then on Monday, you'll pick up all the lesson from 10.5 again.